So this video is going to be on how to evaluate and how to do the operations with functions. So operations as in adding, subtracting, multiplying, and dividing two functions with each other. So first we want to go through and write the definition of a function. So a function defined is a relationship between two values such that each input, which we think of as an x value, has exactly one output, which we typically think of as a y value. So each input has exactly one output. So here are some examples of functions, and these are not necessarily new to you. You've seen these before. You might not have called them functions, but you have worked with them before. So for example, most recently you guys have worked with quadratics. That's way more U-shaped than they typically were, but an equation like y equals x squared, you've worked with that equation before. That's a quadratic equation or a parabola. In Math 2, you worked with square roots, y equals the square root of x. We have worked a little bit with polynomials. You've seen their equations a little bit more than actually seen their graphs probably, but they look something like this. That is a function. Another example of a function, if we were to look at it in a table, in an x and a y table, would be an input of -3, an output of 2, input of 4, output of 1, input of 7, output of 1. So each x value has its own y value. You can see the x values are not repeated, they have their own y value. So a special little note about functions is they pass the vertical line test. The vertical line test, some people call it the pencil test, means that you could take your pencil and run it along the graph, and your pencil would only touch one point on the graph at a time. It would only touch one point on the graph at a time. So for instance, if I was to turn this sideways, that would not pass the vertical line test because my pencil is touching 2 points on the graph at a time. But normally it passes the vertical line test because a parabola is a function. And typically, if you think about all the different equations that we've studied so far, absolute value, quadratic, square root, we study families of functions, which means that you've been introduced to a lot of functions, you just haven't really called them that in the past. All right, some non-examples. Here is a non-example for you. We have a perfect circle. Let's see if I can kind of draw it that way. There's a perfect circle. That is not a function. And if you can look here, we count 1, 2. This has an x coordinate of 2, and so does this. So they both have the same input, but this point up here would have a positive y coordinate, and this point down here would have a negative y coordinate. So you have the same input, the same x value, with two different y values. Same thing over here, if I was to take a parabola and flip it on its side, we could have the same x value input. I'll go ahead and use 2 again. We could say x equals 2 and x equals 2. the same input with two different outputs. In fact, if you were to write the equation for this parabola, that equation would be x equals y squared. And if you were to go a step further and try to solve that for y, get the y alone, that would be y equals positive and negative square root x. Positive square root x for the top, negative square root x for the bottom. And that's actually what makes it so it's not a function. You have two different outputs for the same input. Positive 2, plus or minus for your outputs. In table form, we have an x and a y table. Input -3, output 1. Input -2, output 5. Input -3, output 6. This is not a function because we have two inputs that have different outputs. Plug in -3, get 1, or plug in -3, get 6. It is not predictable. So in an old math textbook that I used to use, they likened it to a soda machine where you could press a button and sometimes it'd give you Mountain Dew and sometimes it would give you Pepsi, and each time you press the button you were not sure what one you would get. The outcome is not predictable. So here you can plug something in and every single time you know what y value you're going to get. That's a function. Here you could plug in one number, but your output is not as predictable. It could be two different values. That makes it not a function. All right, so examples, non-examples. These do not pass the vertical line test. You can see that my vertical line is touching two places of the circle at the same time. So it does not pass the vertical line test. All right, some notation for us. In the past, we often wrote y equals and then we had our equation. Now we're going to often use f of x, or a function in terms of x. So f of x is shorthand, and that is shorthand for a function in terms of x. Now, most people don't say that. That's a mouthful, so f of x is the way that you can say that, a function in terms of x. So we're going to work with the same equations we did before. We're just going to see f of x written more often. We're going to see y written less often. Y and f of x are interchangeable. They are synonyms. They mean the same thing. The reason that we like to switch this notation is we can have f of x, we can have g of x, we can have h of x, k of x, l of x, m of x, all different ones, and it's a good way to differentiate between different equations when you have several. When you're using y equals for everything, then it's confusing because you've just got y equals, y equals, y equals, and if you've got three equations, it's hard to determine which one you're talking about. So if we have something like y equals 3x plus 5, back before we were working with functions, they might have given you instructions where they said find y when x equals 2. And so you'd say, okay, I'll go ahead and I will take the 2 and I will plug it in for x. So you'd write y equals 3 times 2 plus 5. And then you'd get y equals 6 plus 5. And at the end, you'd say, all right, y equals 11. And then you would know, all right, when you have an x coordinate of 2, you have a y coordinate of 11. And you'd be finished. In function notation, they would say, okay, the beginning of the problem is f of x equals 3x plus 5. And they wouldn't write out that whole sentence. They would just say, find f of 2. That's all they would say. Find f of 2. And so you would look at that problem. I'm going to do this in different colors. You would look at that problem and you would go, okay, so the 2 is in the same place where the x is. And so you would find the x in the equation and you would replace it with the 2. So you'd say, all right, f of 2 equals 3 times 2 plus 5. F of 2 equals 6 plus 5. F of 2 equals 11. Now, the nice thing about this function notation is you don't really have to do that final step of saying, oh, there's a point here when the x-coordinate is 2, the y-coordinate is 11, because in the function notation, you can see I plugged in 2 to get 11. It's not like this where you get, oh, the y-coordinate is 11. Oh, what was the x-coordinate? What did we plug in? You know in the function notation, I plugged in 2, I got 11 as the answer. So that's one of the perks of function notation, is that what you plugged in is part of the answer. That makes it a little bit interesting. Okay, so this is all just kind of the introduction to functions, function notation, all of that. We're going to go ahead and move on to some evaluating. So when I say evaluate, I mean that we're going to be plugging numbers in, we're going to be getting answers. So evaluating. All right, evaluating. So on your sheet, we're going to work with a few different functions when we're evaluating. So go ahead and write these down. We're going to have f of x equals 3x minus 7. We're going to have g of x equals x squared minus x. H of x equals negative x to the third. And m of x equals negative absolute value of x plus 1. So those are the 4 functions that we're going to work with. And then we're going to do examples based off of those. All right, so here is example 1. We are going to find g of negative 4. We're going to find g of negative 4. So if we're finding g of negative 4, I'm going to go ahead and start with g of x. And I can see that they are taking the x and they are having us replace the x with a negative 4. And if I look here, I've got 3 places where the x's are. So I've got g of negative 4, this is my notation, and I've got negative 4 squared, and anytime I plug in negative 4, and I'm going to have to put it in parentheses, so negative 4 squared minus negative 4. So I had 3 places where the x's were. One of them was just the notation for functions, and then the other spot was actually plugging in the negative 4 for the x. Now I can go ahead and simplify. Negative 4 squared is positive 16. Minus negative 4, minus minus makes a plus. That's plus 4, and so this equals 20. Now I can drop my notation down. G of negative 4 equals 20. So if I wanted to know what that coordinate was on the graph, it'd be negative 4 for the x-coordinate, 20 for the y-coordinate. Negative 4, comma 20. All right, next example. Let's go ahead and find h of negative 2. So I'm going to start off by writing h of x down. So h of x is negative x to the third. So I can see that I'm plugging something in for x. I've got the x here with my notation. I have the x here that I'm going to be plugging the number in for. So I have h of negative 2. And then I've got negative, and I'm plugging the number in right here, negative 2 to the third. So I had 2 x's, I had 2 places where I was going to plug the negative 2 in, and then I plugged the negative 2 into both of those places, one for the notation, and then one for actually getting the number plugged in. right? So I'm going to be careful about my order of operations. I know that I should not cancel out these negatives. I need to do the third power first. So I've got negative of negative 2 to the third power is negative 2 times negative 2 times negative 2. That's negative 8. And then I can say negative times negative is a positive, and so this is positive 8. And then I can go ahead and drop my notation down. H of negative 2 is positive 8. All right, this time let's go ahead and find 2 times m of negative 1. All right, so I'm going to go ahead and write down this problem. I've got m of x. So I'm going to write down m of x. That is negative absolute value of x plus 1. I'll write this first, m of x. I'm going to leave a little space because I've got the 2. So I've got negative absolute value of x plus 1. And then what I'm going to do is I'm going to put parentheses around that. I'm going to do this part in green so you can really see what I'm doing. This has a coefficient of 2, so I'm going to stick the coefficient of 2 in there. I'm going to stick the coefficient of 2 in there. I am going to leave that coefficient of 2 to the very end of the problem. All right? Now I'm going to look and see where I'm plugging in that negative 1. So I can see there's an x right here. There's an x right there. That is where I need to plug in that negative 1. So I have 2 times m of negative 1, 2, and then I've got negative absolute value, negative 1 plus 1, like that. And now I do my order of operations. So order of operations are basically you're starting from the inside and working your way out, which is why that multiplication of 2 is not going to work until the very end of the problem. So I'm starting inside my absolute value signs. I've got negative 1 plus 1 is 0. So I've got the negative version of 0, the 2. Now the negative version of 0 is just 0. So I got 2 times 0. And that's just 0. So I'm going to drop my notation down now. I've got 2 times m of negative 1 equals 0. Okay, we're going to do one more for good measure. We didn't quite get to the operating with, well, we're kind of going to do it with this one, but we're going to do more examples in class to finish up the notes. We will do a little bit of operating with this example. We're going to do find 3f of 0 minus m of negative 6. So you can see here we're going to be subtracting two different functions. We're going to do f minus m, but we are going to do more of the evaluating more of the function operations in class when we do our class notes. So this is going to be our last example with the video, but we will continue on with this in class using those same 4 functions. So I'm going to go ahead and write this down. I have f of 0. I'm going to have a 3 in front of it. So I'm going to leave some space. So I'm going to have 3f of x minus m of x. I'm going to go ahead and write the 3 again with the green so I can really see what I'm doing here. So 3f of x minus m of x. I'm going to go ahead and write this out. 3, my f of x is 3x minus 7 minus, and then I've got my m of x. I'm going to put this in a big parenthesis. My m of x is negative x plus 1. Okay. So now I've got to think about what I'm plugging in. Now you'll notice I'm plugging one number in for f of x, but a different number in for m of x. So I'm going to go ahead and just work with the f of x first. So here's the f of x, and then here's the f of x, and I'm going to go ahead and get started there. I'm going to keep green So whenever you're doing colors, do just enough to make sure that you're not confusing yourself. I do really think that using colors, well, you guys know I love using colors to help keep myself from getting confused with things. So 3 times, and then here I've got 3 times 0 minus 7 minus, okay? And then now I've got a number, I'm going to have to plug something in for the x with the function for m. So I've got this x right here, and then over there I've got this x. So I'm plugging it in right there. So I've got -6 is what I'm plugging in. -6 plus 1. Okay, so let's go ahead and write down what we've got. We've got this 3. We've got 0 minus 7. Got that negative. Got that negative. -6 plus 1 is -5. Okay? 0 minus 7 is -7. Minus. The absolute value of -5 is just +5. So that's just +5. Okay? Now here we got the minus makes a plus. Okay? So we've got 3 times -7 is -21 plus 5. And then -21 plus 5 is -16. So it appears that 3 times f of 0 minus m of -6 equals -16. Now, I've been doing all the plugging in of the numbers by hand just to kind of strengthen order of operations. By hand, doing it in your head, PEMDAS, all of that. But technically, as soon as you got to the step of plugging in the numbers, you could type that in your calculator. All right, so we are done with the examples on the video. We are going to continue more of this tomorrow in class.